200 US dollars will be invested for developing quantum hardware. Rest of the amount, remaining 200 US dollars in billion will be invested for, services and software. So this is the recent development in the field of QKD done by China. China has made a great achievement in this field, QKD. Many countries have done a lot of researches for point-to-point and point-to-multi-point quantum key distribution protocols. In the year 2021, they started QKD, and followed by that, many countries have done QKD in various years. In 2009, Japan has implemented QKD. 2010, 2016, in Beijing they have implemented QKD, but very recently, China has done QKD for 2000 kilometers between Beijing and Shanghai. So when they implemented this quantum key distribution protocol between Beijing and Shanghai, they used 32 trusted nodes here. Why trusted nodes are used here means because the communications are performed in the form of fiber optics. So when we use fiber optics for performing the quantum communications, the signals will be transmitted in the form of photons. So we cannot use normal repeaters for performing the QKD. Therefore, trusted nodes are used for sending the quantum keys from one source to another destination. Now, China has achieved a big achievement for sending the quantum keys between 2000 kilometers. Now they are focusing on QKD on space, which means that between the 2 points on Earth, one point may be China, the other point may be US. Between the 2 points on Earth, they are doing research of transmitting the quantum keys. And this is the national level status for quantum computing. Our Honorable Minister, our Honorable Prime Minister Narendra Modi ji has allotted 6,004 crores for the development of quantum computing, and we have formed the National Quantum Mission in our country, which focuses on 4 different dimensions. One dimension is quantum computing, the other one is quantum sensing, and the third one is quantum communication and quantum material and devices. Related to quantum computing, IISc Bangalore is doing a lot of research, and quantum computing related to that, IIT Madras is doing many researches with the help of DDOT. Then IIT Bombay is doing quantum sensing and metrology related things. IIT Delhi is focusing on quantum materials and devices. Apart from this, DRDO has committed 700 crores for developing various things related to this National Quantum Mission project. And this is the QKD which is implemented in India. Initially, we tested the QKD between 10 kilometers at Hyderabad in the year 2020, and a field testing was done between Prayaraj and Vindhyachal in Uttar Pradesh in the year 2022. So the total distance taken for sending the quantum keys between the source and destination is 100 kilometers. In India, we have successfully completed QKD between 2 nodes for 100 kilometers. In this QKD, they also performed an eavesdropping attack. They introduced an eave in between the source and destination, but he was not able to find the key successfully. And this is the overall comparison for international and national status of quantum computing. In international level, using superconducting devices, IBM has developed a quantum simulator, or I would say that's quantum hardware that supports 1121 qubits, and its name is Condor. Google has developed a quantum hardware, and its name is Sycamore, that can support maximum of 53 qubits. But in national level, in India, we have developed 6-bit quantum hardware. Other than that, we have fixed the target for developing 24 qubit computer very soon. And in another 8 years, India has fixed the target to develop 52,000 qubits computers in another 8 years. And using semiconductor devices, 12 qubit quantum computers developed, and based on the photonic concept, that is optical fiber based concepts, in international level, one quantum computer is developed which can support 216 qubits, and in India level we have a quantum computer that can support 2 qubits. From this presentation, I want to highlight one of the important things. China develops record-breaking 5 not 4 qubit quantum computer according to the press release, and the citation is given in this slide. So after seeing this, it is clearly understood that quantum computer is developed by many companies, and it is clearly understood that all the encryption algorithms which are based on classical computers are easy to break. In the year 1972, 2000, we were using DES for performing the private key based encryption operations, and it was broken by some computer. So we moved from DES to triple DES. It was also broken by some hackers. Then they developed a new encryption algorithm, AES, is based on Galois field, and followed by that ECC, elliptical cryptography, was developed. AES is a private key cryptography, and ECC is a public key cryptography. Followed by that, from 2000 to present day, we are using RSA in many banking applications. But after developing all these private key and public key encryption algorithms, if quantum computer comes into the market, it will break all the encryption and decryption algorithms. So definitely it will break all the private and public key encryption algorithms, because quantum computer supports 2 important properties: superposition and quantum entanglement. Therefore, it is time for us to enter into post-quantum cryptography in order to prevent the